Hi, good evening, everyone. Today we're going to talk about metal can defects. These defects can occur at various stages of can production. Specifically from raw metal plate up until the final handling. Understanding these defects is essential in a way that it ensures safety and also high quality canned products. First, we have the metal plate manufacturing defect. One of the most common issues is plate fracture. This happens when the metal sheet cracks during the forming process. It can be caused by using metal that is too hard, too thin, or improperly processed, such as metal that hasn't been annealed correctly. Cracks can also form if the metal is overstressed during rolling or if impurities are present in the metal. These fractures weaken the can, potentially causing leaks and making the can more prone to failure during sterilization or shipping. Annealing is a heat treatment process that softens the metal, making it less brittle and more flexible. If this tip is skipped or not properly controlled, the metal can become too hard, leading to cracks when it is rolled, bent, or formed into can shapes. Overstressing the metal during rolling can also lead to fractures. For example, if the rollers apply too much pressure or the metal is passed through the rollers quickly, the sheet may crack along weak points. Impurities in the metal, such as slag or foreign particles, can also create stress points that lead to fractures under pressure. These fractures are a serious problem because they weaken the can, making it more prone to leaks and structural failure during sterilization, shipping, or storage.
Metal plates seem tough, right? We use them in buildings, bridges, even cars. But sometimes these plates have hidden problems, fractures. Fractures are cracks and they can be dangerous. A cracked plate is weaker and might break completely under stress. These cracks don't just happen. They usually start during the manufacturing process. If the metal isn't treated right, it becomes prone to cracking when bent or shaped. Think of it like bending a thin piece of wood. Bend it too far and it snaps. Metal can act the same way if it's not strong enough or prepared properly. One big reason for fractures is using the wrong kind of metal. If the metal is too hard, it's like that brittle wood. It snaps instead of bending. Metal that's too thin is also a problem. It doesn't have the strength to handle being shaped. Another culprit is improper processing. Metal goes through lots of steps like heating and cooling to make it strong. If these steps aren't done right, the metal's insides can be messed up. It might look good on the outside, but it's weak on the inside, ready to crack. One important process is called annealing. Imagine metal as a bunch of tiny metal grains all stuck together. Working the metal can make these grains squished and stressed out. Annealing is like giving the metal a relaxing spa day. We heat the metal up and then let it cool down slowly. This lets the metal grains relax and rearrange, making the metal less stressed and less likely to crack. It's like taking a break when you're working hard. It helps you come back stronger. Another way fractures happen is through overstressing during rolling. Rolling is when we squeeze metal between rollers to make it thinner and longer. Think of it like rolling out dough, but with giant metal rollers. If we roll the metal too much, it gets stretched too thin. This is like stretching a rubber band too far. Eventually it snaps. The same thing can happen to metal if we're not careful. It gets too thin and weak, and then cracks can form.
Next we have the coating application defect. Example for this is blistering. This happens when the protective coating on the inside or outside of the can bubbles or lifts away from the metal surface. This can be caused by trapped air, moisture, or improper drying during the coating process. Blisters can also form if the coating is applied too thickly or if the curing temperature is not properly controlled. Over time, these blisters can break, exposing the metal to moisture, which leads to rust and potential product contamination. Blistering is especially dangerous because it exposes the bare metal to the can's contents or the outside environment. so leading to rust, corrosion, and contamination. So in food cans, this can result in off flavors, discoloration, and even chemical contamination as the metal reacts with the food. So preventing blistering requires careful control of the coating process, so including maintaining the right temperature, humidity, and coating thickness. So regular inspections and proper equipment maintenance are also critical to prevent this issue.
You know those cans you see every day, the ones holding your food, drinks and other stuff? They have a tough job. Got to protect what's inside from the outside world. That's where coatings come in. Like a shield, they keep air, moisture and other bad actors at bay, but sometimes things go wrong. The coating, instead of laying flat and smooth, bubbles up. That, my friend, is blistering. Not a good look. Not good at all. Picture this. You're opening a can of soup expecting a warm, comforting meal, but wait, what's that under the label? Bubbles. The coating's lifting, revealing the metal underneath. Not appetizing, right? That's blistering in action. It's like a tiny air pocket trapped between the can and the coating, pushing it up and creating an unsightly bump. So why does this happen? Well, imagine painting a wall on a humid day. The paint dries too fast, trapping moisture underneath. Same idea with coatings. Too much moisture in the air, or even in the can itself, can get stuck under the coating as it dries. Bam, blisters. But it's not just moisture. Think about applying too much paint on that wall. It'll drip, sag, and maybe even bubble. Same goes for coatings. Too thick, and it's a recipe for disaster. The outer layer dries before the inner layer, trapping solvents and causing, you guessed it, blisters. Then there's temperature, too hot or too cold during the curing process, and the coating won't adhere properly. Like trying to bake a cake at the wrong temperature, it just won't set right. And let's not forget about the surface itself. If it's dirty, rusty, or not prepped correctly, the coating won't stick, leading to, say it with me, more blisters. Now, you might be thinking, okay, blisters are ugly, but are they really a big deal? You bet they are. Remember that protective shield we talked about? Well, a blister is like a chink in that armor. It exposes the metal underneath to the elements, opening the door to rust and corrosion. Think about a can of food. If the coating blisters and the metal underneath rusts, guess what can leach into your food? Not something you want to think about, right? And it's not just rust. Those blisters can trap bacteria and other contaminants, turning your once safe food into a potential health hazard. So how do we fight back against these pesky blisters? First off, control. We need to control the environment. Keep the humidity in check, make sure the coating is applied at the right thickness, and get that temperature just right. It's like baking, only with industrial coatings instead of cake batter. Next up, regular inspections. Think of it like a routine checkup at the doctor. Got to catch those blisters early before they turn into major problems. And just like you need to maintain your car, regular equipment maintenance is key. Clean those spray guns, calibrate those ovens, and keep everything running smoothly. Remember folks, preventing blistering is a team effort. From the guys on the factory floor to the quality control crew, everyone plays a part. By working together, we can keep those coatings smooth, strong, and blister-free.
So the third is can body manufacturing defects. So example for this is body dent. So this happens when the can is bumped or compressed during forming, handling, or assembly. So dents weaken the can, potentially affecting the seam and increasing the risk of leaks. So they can also lead to problems during labeling, stacking, and shipping, making the can less appealing to customers. So dents can occur for many reasons, including rough handling during production, and then improperly sit guides on the production line, or collisions with other cans. So even a small dent can put stress on the can seams, which are critical for maintaining a tight, airtight seal. So in severe cases, dents can compromise the structural integrity of the entire can, making it more likely to burst or leak under pressure. So, to prevent dents, manufacturers should use proper can handling equipment, implement strict quality checks, and also train workers to handle cans with care.
Can body dents are a prevalent issue in can manufacturing. These imperfections, though seemingly minor, can significantly impact product quality and consumer perception. Dents can occur at various stages of production, from the initial handling of sheet metal to the final packaging stages. Understanding the causes and consequences of dents is crucial for manufacturers to maintain high standards of production. While consumers may overlook minor cosmetic imperfections, dents can be more than just an aesthetic issue. They can compromise the integrity of the can, potentially leading to leaks, spoilage, and safety concerns. Therefore, addressing this manufacturing defect is vital for ensuring product quality and consumer satisfaction. Dents in cans can occur due to several reasons, often related to mechanical stresses and impacts during the manufacturing process. One common cause is improper handling of the can bodies during transfer between different stages of production. Dropping cans, even from a small height, can lead to dents, especially if they land on an uneven surface. Another cause is malfunctioning equipment. If the machinery responsible for forming, filling, or sealing the cans is not calibrated correctly, it can exert uneven pressure on the can bodies, resulting in dents. Furthermore, worn-out parts or a lack of regular maintenance can contribute to equipment malfunction and increase the likelihood of dents. Dents, particularly those along the seams or edges of the can, can compromise its hermetic seal. This seal is crucial for preserving the freshness and quality of the contents by preventing the entry of air and microorganisms. A compromised seal can lead to product spoilage, reducing its shelf life and making it unsafe for consumption. Beyond the functional issues, dents also significantly detract from the product's visual appeal. Consumers often associate dents with damaged or low-quality goods. This perception can lead to reduced consumer confidence and affect purchasing decisions. A dented can might be perceived as old, mishandled, or even tampered with, discouraging consumers from choosing it over a pristine alternative. Preventing dents requires a multi-pronged approach that addresses various aspects of the manufacturing process. Firstly, investing in well-maintained, high-quality equipment is essential. Regular servicing and calibration of machinery can minimize the risk of malfunctions that could lead to dents. Secondly, training employees on proper handling techniques is crucial. Workers should be educated on the importance of careful handling, especially during transportation and transfer. Emphasize the use of appropriate tools and equipment to move cans, minimizing manual handling and the risk of accidental drops. Lastly, implementing robust quality control measures at each stage of production is vital. Visual inspections, automated scanning systems, and regular equipment checks can help identify and rectify issues promptly. By incorporating these preventative measures, manufacturers can significantly reduce the occurrence of can body dents, ensuring product quality and preserving consumer trust.
So the fourth one is the can end manufacturing defect. So example for this is curl defect. So this happens when the edge of the can end, which forms the critical seal with the can body, is not properly shaped. So this can be due to incorrect tooling, poor material quality, or improper handling. So a poorly formed coil can prevent a tight double seam from forming, leading to leaks and also spoilage. So, the coil of a can end is carefully designed to form a tight, so secure seam with the body of the can. If the coil is too loose or uneven, it can prevent the double seam from forming correctly, so leading to leaks and potential spoilage. So this can happen if the end material is too hard, the coil tooling is worn, or the forming process is not properly controlled. So to avoid coil defects, regular maintenance or forming tools and strict quality checks are essential.
Can ends are essential in the packaging industry. They seal contents, ensuring freshness and safety. A well-made can end protects products from damage and contamination. The curl is a critical part of the can end. The curl is a rolled edge that forms a secure seal with the can body. This seal prevents leaks and preserves product quality. A precise curl is crucial for the can's integrity. Curl defects are imperfections in the can end's curl. These defects can compromise the can's seal, leading to leaks and spoilage. Common curl defects include short curls, long curls, and wavy curls. A short curl doesn't reach the can body properly, resulting in a weak seal. Conversely, a long curl can interfere with the seaming process. Wavy curls create an uneven seal, increasing the risk of leaks. These defects can occur at various stages of the manufacturing process. Identifying the root cause is essential for implementing effective solutions. Tooling issues are a common cause of curl defects. Worn-out dies or improperly set rollers can lead to inconsistent curl formation. Regular tool maintenance and timely replacement are essential for preventing these issues. Material quality also plays a role. Variations in metal thickness or hardness can affect curl formation. Using consistent, high-quality materials is crucial for maintaining curl consistency. Improper handling during manufacturing can also cause curl defects. Mishandling can ends or dropping them can deform the curl, compromising its integrity. Careful handling throughout the production process is essential. Preventing curl defects requires a multi-pronged approach. Regular maintenance of tooling equipment is essential. This includes inspecting dies, rollers, and other components for wear and tear. Quality checks at various stages of production are crucial. This includes inspecting the curl after each forming operation. Early detection of defects allows for timely adjustments to the process. Proper training for machine operators is also important. Operators should be knowledgeable about curl formation and the factors that can affect it. This knowledge empowers them to maintain consistent quality. By focusing on prevention and quality control, manufacturers can minimize curl defects, reduce waste, and ensure the production of high-quality, reliable cans.
So the next is the double seam defect. Example for this is droop. So actually, droop occurs when the body and end of the can are not properly interlocked, so leaving a visible gap or overhang. So this can result from incorrect seamer setup, damaged seaming rolls, or improper material feed. So droop is dangerous because it can allow air, bacteria, or other contaminants to enter the can, so risking product spoilage and health hazard for consumers.
A double seam is a critical part of a can. It's the multiple layers of metal tightly joined together to seal the food inside. A properly formed double seam is vital for preserving food safety and quality. However, sometimes defects can occur during the seaming process. One such defect is called droop. Droop is a type of double seam defect that appears as a sharp downward slope or dip in the seam. This dip happens when the seaming machine doesn't properly compress the metal layers. Instead of a smooth, even seam, you get a noticeable dip. This usually happens at the overlap where the two ends of the can's lid meet. This defect weakens the integrity of the seal. A weak seal can allow air and contaminants to enter the can. This is a serious food safety concern. Droop is often caused by problems with the seaming machine itself. Incorrect machine setup is a major culprit. If the seaming rollers aren't properly aligned or adjusted, they won't apply the correct pressure to the seam. This can result in a droop defect. Worn or damaged seaming rolls are another common cause of droop. Over time, the rolls can become worn down or develop grooves. These imperfections can prevent the rolls from properly shaping and sealing the seam. Regular maintenance and timely replacement of worn parts are crucial. This ensures the seaming machine operates at peak performance. A proper double seam acts as a barrier between the food inside the can and the outside environment. It prevents air and microorganisms from entering the can and spoiling the food. The seam also helps maintain the pressure inside the can, which is essential for preserving the food. When a can is sealed with a proper double seam, it creates a hermetic seal. This means it's airtight and impermeable to microorganisms. This seal is essential for preventing the growth of harmful bacteria that can cause food poisoning. A well-formed double seam ensures the food inside remains safe, nutritious, and flavorful for its intended shelf life. Droop in a double seam is a serious food safety issue. Because it compromises the hermetic seal of the can, it can lead to food spoilage. Air and microorganisms can enter the can through the defect. This can cause the food to spoil more quickly. More importantly, droop can allow harmful bacteria to contaminate the food. This contamination can have serious health consequences for consumers. Consuming food from a can with a droop defect can lead to food poisoning. Regular inspections of double seams and proper maintenance of seaming machines are essential to prevent these risks.
And then we have the other manufacturing defects. Example for this is misformed seams. So occur if the can seamer is not properly adjusted or if the can body or ends are poorly made. So misformed seams can look wrinkled, loose, or uneven, and they can significantly weaken the can, increasing the risk of leaks or contamination. So actually, seam formation is a complex process that requires precise control of metal thickness, alignment, and also pressure. So any misalignment or inconsistency can lead to misformed seams, which can significantly weaken the can structure. So regular maintenance, operator training, and also detailed seam inspections are crucial to avoid these defects.
Cans are ubiquitous. We find them everywhere, holding our food and beverages. These metal containers seem simple, but their production is complex. It relies on precision at every step. A critical aspect is the formation of the seam. This joins the can body and end. A well-formed seam is vital. It ensures the can's integrity and safety. Misformed seams, however, pose significant risks. Several factors can lead to misformed seams. One common cause is improper adjustment of the can seamer. This machine plays a crucial role. It needs regular maintenance and calibration. Another factor is the quality of the can bodies and ends. These components must meet strict specifications. Inconsistencies in metal thickness can also create problems. If the metal is too thick or too thin, it can affect seam formation. Environmental factors such as temperature and humidity can also influence the process. These variations can lead to inconsistencies. Misformed seams compromise the integrity of the can. These defects can weaken the can's structure. This makes it susceptible to damage. Leaks can occur, spoiling the contents. Worse, contaminants can enter the can. This poses serious health risks to consumers. Such incidents can damage a company's reputation. Recalls may be necessary, leading to financial losses. Preventing misformed seams is paramount. This requires a multifaceted approach. Regular maintenance of can seamers is crucial. Trained operators are essential. They must understand the importance of proper machine setup and operation. Detailed seam inspections are also critical. This helps identify and address defects early on. By prioritizing these measures, manufacturers can ensure the production of safe and reliable cans. Consumers can have confidence in the products they purchase.
So last we have the handling defect. So its example is impact damage. So this happens after the can leaves the factory, usually during transport, storage, or retail handling. So impact damage can include dents, scratches, or even complete deformations. So these defects weaken the can, make it more likely to leak or burst under pressure. So proper handling and careful stacking are essential to avoid these issues.
Hey there! Today I want to talk about something super important for the canning industry. Impact damage during handling. Yep, those pesky dents, scratches and deformations that can really mess things up. So, what exactly is impact damage? This type of defect usually happens after the can leaves the factory. It could be during transport, storage, or even while it's sitting on a retail shelf. Essentially, any time the can is moved around, it's at risk. Now, why should you care? Well, for starters, impact damage weakens the can. This makes it more likely to leak or even burst under pressure. Imagine a can bursting on the shelf. Talk about a mess. To prevent this, proper handling is key. Always ensure that cans are carefully stacked. Use protective packaging and avoid stacking them too high. If you're transporting them, make sure they're secure and cushioned. And remember, even scratches can be a big deal. They might seem minor, but they can compromise the can's integrity. So, always check for scratches and handle the cans with care. In summary, impact damage can be a real problem, but with proper handling and stacking, you can keep your cans in top shape. Thanks for watching, and stay tuned for more tips on keeping your canned products safe and sound. Catch you next time.
So in summary, understanding these defects is critical for maintaining the quality and safety of canned products. So regular inspections, proper material selection, and careful handling are the key to preventing these problems.